Welcome to a new test and teardown video. This time it's something completely different. Let me see if I can show you this logo here. It says Signaal with two A's, so it's a little bit weird to Google. So that is a Dutch company making military, aerospace, all sorts of fancy avionic electronics. And this one is a unit called 1125. And there's a little hint here. It's called Err Detec. So I think it's an error detector for some sort of a military aircraft or something like that. I just wanted to show you the internals of this unit because everything here is built to a super top-end, high-class quality level. And I think we should just go and look at all the different design details here that will give it very, very high reliability. So that is the other side of the unit. I think there's some sort of a data radio interface with some modem kind of features. We got a crystal filter. We got some SMA connectors. There's one right here, and there's another one down here. Nice shielded, isolated rooms for everything. See a little inductor, so there's maybe a VCO and some mixing and some injection going on right there. Could also be some PLLs. All the ICs and all the transistors. Let me see if I can show you guys this. Can you see all the numbers? Serial numbers written or stamped on each device. And it's because everything is tested before it was mounted. See, also here on other important parts, we got all the numbers here. So they can be tracked and traced, and certificates found for each little testings. See the transistors on top of those transistors. Let me see if I can get this handwritten numbers, and there's a very, very thick layer of not stone hard but a little bit soft kind of varnish, and it was not sprayed but it was hand painted. You can see it in this area here. It's painted and then it's dripped down, and this is because they don't want it on all the different surfaces, and they don't want it in the assembly joints for all the mechanics, and definitely not into connectors and stuff like that. So it had to be painted by hand, and also they didn't put it down deep down into all the screws, so you can still access all the screws. So that is also a pretty neat detail. See, I think this is a mixer, and we got two SMA connectors going to that mixer, revealing we have some sort of an input-output something going on here. Also note the different resistor types they're using here. That is also the very, very top class of components. Oh yeah, I can probably show you some even wilder high precision components, but they are on the other side. But no, yeah, they're also here. You see those resistors? I think they're between $10 and $20 for one resistor, and they're 0.01 ohm. They're from Wishay. So we got, I think it is 3 digits after the decimal in their values. So nothing, no expense spared, but still, see a little bit of modifications. And power supply going into this board. going through filters. Inside here we have some inductors and capacitors, so those are called feed-through filters. They're really, really good to keep all the noise away from coming into your circuit. And there's another thing you can see here. Those are called connector savers. And the idea with connector savers is that during production, testing, and until final assembly into the aircraft, you have these savers mounted. So all the matings that you have to do to connect to this instrument here is done on those. And then you save the connectors, only one mating when it's assembled first, and then one mating again when this unit is installed into the aircraft. This way, the connectors, they are super good and reliable, and all the gold is still left on the contacts. A single ground star point is here, and I think it's really fascinating. There's a screw on the outside where you shield it, and of course it's also mounted. The frame is also mounted to the chassis of the aircraft, but then there's an additional wire here, and that is of course if the screws goes loose. Of course you still want this unit to work correctly. And look at the many wires going to that point and how they are soldered and carefully handled. I think it's just amazing. All those white wires, they're Teflon wires, so it's super high temperature, high quality product. And all the wires that goes to the circuit board, you need to see that little detail here. They go through a hole in the circuit board. Can you see all the holes where the wires go through? And then they're soldered on the other side. Let me flip this a little bit and let's see the solderings. So the wires come through the holes and then see, bend to a point where you do the soldering. And look at the quality of that. All the wires are exactly the same length, and all the soldering, they look exactly the same. That is just amazing. And also, normally when you tie cables like this, you just do one little knot, and then you take your your wire, and then you go around and around and around and around, and then you tie another knot in the end. But no way. Let's do it the best possible way, and that is of course to tie it up individually, so that if something gets loose, it's not going to affect anything else. I think that is a really, really cool detail. And for vibrations, see again, we got this piece of metal here that goes all the way up here, and then it is stabilizing all the wires all the way, so there's no vibrations causing any, I don't know what you call this, causing breaks or cracks into the solderings. And again, all this is also coated again with the same varnish, so nothing here is gonna get loose. Talking about high quality. I think this unit is from about 84. I think this is the highest date code I can find. Again, you'll find all military special type numbers on all those ICs, so it's not really easy to look up what these things are doing. See here again, we got some, I think those are mixers or something. Again, hand engraved numbers on those two transistors or whatever those are. And we got some adjustments here in the very middle. Can you see there's a resistor standing up? Again, it's one of those Vishay super high precision resistors, and it's standing up like that. And that is because this way it's better to glue it to the circuit board. And it's also a good way to avoid stress to the component. So this is something really, really important. And to the right of it, there is another little resistor that is not the same kind of high precision. And there's another one. Where is that? Yeah, here you go. In the middle of the picture again. See, it is the same Vichy resistor. Yeah, it's just, this is just, I don't get this kind of a quality level into my lab every day. So I really wanted to show you guys, this is also the way that some people do stuff. It looks exactly the same for space, by the way, but then you have no ceramic ICs or ceramic transistors. It's all in metal and gold-plated metal everywhere. There isn't any plastic part or ceramic parts like this in space. But other than that, it looks exactly like this quality level. So I think this is more or less what I wanted to show you. I just didn't really want to go super duper deep into or taking this apart or anything. I think it is super cool and sexy to keep it as it is, as a little showpiece of what kind of quality level do you want. Do you have unlimited amount of money? Then we can do it like this. But I think only military and space can afford this kind of reliability and this kind of quality level. So thank you very much for watching this short video. That was definitely something completely different. I hope to see you soon again. Bye.